I'm Major. Today I will continue to show you how to do the multiple choice for the HKIA exam. First of all, you need to see more, and then you can understand how to do it, and you will find it much more easy if you see all the videos from me. Okay, this one is talking about the twisting and something the lateral load. And you first of all you need to understand something is twisting, they will have a torsion like this photo, and that's why also show you some of the building they will have a lot symmetric layout, and then they will form a torsion. That means most likely you see this building they will use the rigid thing just like the core wall to take the torsional force. If the building they also use the bracing to take the torsion, and since this is the forces for the building, that's why for the foundation type there's no use, and that's why you need to take out 3 and 4. That means the first one you need to understand the twisting is normally used, then the lateral whacking is something like this for the building, and then you take out all something for related to foundation. That means 1 and 2 is correct, and this one is you need to understand this is a very basic principle, is what type of so-called rigid joint or the pin joint. And for this one you need to understand this is the pin joint, and then that means they can rotate, they cannot take any moment. You need to understand if I want to resist the moment, it must be a fixed joint. That means if I want to rotate something, if I want to resist this one should be fixed. If this one can be moved, it cannot take the so-called moment. This is the normal requirement. That's why if they are not jointing, is a welding, then they can resist the bending moment. For example, this one, the bow and nut is too close together, and you can imagine if I move something, the jointing is moving and cannot take the bending moment. Also for the precast beam, they just rest on the so-called corbel, and then they cannot also call the fixed. That means if you find something is related to fixed and fixed joint, and we can resist the moment, and this is the result we need to choose for item 2. And this one is the this need to require higher loading to resist uplifting. First of all, we need to understand why we see many buildings during the typhoon season the cladding will be pulled out. This is because there's 2 different pressure, and then the internal pressure is much more larger than the outside, and then they will pull outside. That means during the typhoon season you can see sometimes the cases, the window falling out from inside to outside of the buildings. And first of all, you see the building structure is type A, C, and D. They are more or less the same system. They are the truss. Okay, that means the B is a little bit different. There's only 1 member. You can imagine if I need to resist the uplift force, this one should be to take higher forces to take this one. But this one is A is a truss, C is a truss, and D is also a truss. And this one, you need to understand what is the differential settlement and uniform settlement first. If the soil is very weak as a whole, that means the building will be settled uniformly, and that means the settlement is uniform everywhere. But if there's for example, the left hand side is very strong and the right hand side is very weak, for the foundation they will settle much more during the weak layer, and then this will cause differential settlement. This is sometimes you can see the this building, and you can see the right hand side, the soil is very weak, and then the building just to incline to the right hand side and tilting to the right hand side. And that's why the first one, that means if we want to resist differential settlement, it means the right hand side, this one, we need to allow the jointing, and then let them to resist the settlement. That's why we choose this one, because there's a pin joint in here. That means we can allow some movement for the structure, and then it will not be easily settled. And A, B, and C is more or less the same type of arch. Arch is, remember something, is all in compression. If any area with tension, it will be collapsed and not stable. That's why you can see this the old building, and in beach they will form an arch. They just want to have a pure tension. If they induce tension force, it will be collapsed. This is another, the beach. They will use the V-joints type of arch. For example, the right hand side settle a little bit, it will not affect as a whole, and this allows some settlements. This is a so-called V-pin arch. And this is a so-called something like what is the typical design of the retaining wall. This is one of the example. Like the building, we are afraid of the building is overturning and sliding. Sliding is mean if it's subject to force, it move to the left. It's because sliding. And the third one is called the bearing capacity. That means the foundation is not good enough. They will also turning. That means it related to the soil pressure. And this is one of its example. We normally for the design of the retaining wall, we take care of the overturning and sliding and the bearing. Bearing pressure depends on the soil capacity and soil pressure. And this is one of the loading we consider. Most likely, we will not consider the wind load. It will not be quite significant, because you can imagine this is most likely below ground, and the ground levels wind load is very small compared with the soil load. And this is you just remember some of the wording is this is the symbols of small size. We call the K, and the gravel is much more larger. That means you just remember this drawing, you can do how to do it. And sometimes the student thinks the tension stress is in tension zone for the steel reinforcement. Okay, the first one, you need to understand the basic principle is if it's subject to uniform load downward, the bottom one is in tension and the upper one is in compression. That's why normally we put some steel reinforcement to take the tension. But in certain cases, if the compression force is too large, sometimes we also will put reinforcement to enhance the compression zone. That means don't think only B is correct. B is something like the tension stress. That means here we provide the steel reinforcement in the bottom. But some cases, if the compression force is too large, we also will provide some compression bar on the top. Okay, this is that means don't forget A is also correct. And if we understand the steel building, normally if we subject to the lateral force, steel building is most likely we say this is a pinned joint. If we subject to lateral force, it will not stable. That's why normally we need to provide the basing for the steel building. That's why hinged frame cannot be take any lateral forces. This is the building like this. It will be form unstable for the steel frame. That's why if you see a building with a bracing, normally we say this is a steel building. Okay, if you understand that dead load is a so-called the finish load. Automobile is something like the car and carriage. They will have a move in and move out, and this is a moving load, and then we don't think this is the dead load. Okay, and then we normally for this one we regard this is the live load, and that's why you need to understand the dead load is the finish for loading, and the cell waste, something like this we call dead load, and something is a moving, we think this is the live load. And this one is talking about what is the cantilever. Cantilever, first of all, you need to take a look of this picture. If one support does not have any column support, or the steel wire support, or the racking, it means this is the cantilever. Okay, for example, for the item C or D, they have a hanger column. That means the column will take the loading. They have a support from the left and from the right. That means CD will not be the cantilever. And then for the item A, you can see they continues to the B and C. They will also not be regarded as a cantilever. But for the B, you can take a look of this one. This is horizontally going to the left hand side. This is most likely we call this is a cantilever. Sometimes we don't understand the wall foundation and spec foundation. The first one, you need to understand the wall foundation is something like this. This is a very large foundation pad. They will all combine all columns and shear wall together. We call wall foundation. And then the spec footing is normally for the just single element or one or two element. They will support the columns or support the wall. That means they are all, we call they are the same shallow foundation. And sometimes we cannot compare the cost, depends on the size. And then they all take the same loading. That's why they will not take the settlement lot different. And this is also they are the shallow foundation. That means even the different types of soil they can take it. That's why we just take C is a correct one. Okay, and remember if you remember the picture, and then you understand how to do it. This is a very typical phenomenon of the concrete beam. If it's subject uniform load near the support, the loading will be much larger. Remember, if we apply the loading, for example, that means one people in here, one people in here. That means all loading will transfer to the left and to the right. All loading, the load path we call it. That means much loading will be near the support, and that's why this is a common type we provide. See the cracking is a diagonal near the support. That means if you remember this picture, you will understand diagonal near support. And then normally the vertical crack will form near the midpoint, and normally the diagonal will be near the support. That's why we will provide a stirrup in here, or that means diagonal bar in here to take the shear crack. And this one is called what is the duty of the architect. I think you need to understand the framing plan most likely is decided by the engineer. That's why the size of the steel reinforcement, the architect don't need to care. The responsibility should be relied on the so-called engineers, and the size and the beam is suitable for the loading also is the engineer duties. That's why most likely the architect need to take care of the general dimension and then the level of each floor. I think this one you just need to take a look of this drawing. You will understand how to do it. For wall is just a half meter height, and then mostly just use the masonry. It's very economic to take the loading, and if it's only half meter, it's not economic to do the reinforced concrete wall. That's why the first one you need to remember some pictures, and then you will know how to do it. Also, if you understand what is the pile cap, you will understand what is the meaning of this one. Remember, column go down, and then the pile cap will spread all the loading to the pile below. That's why pile cap is transfer the load to piles. This is a so-called, you understand the pile cap wording, and then you understand how to do this one. And most likely you need to understand my basic 3 principles. It will apply most likely most of the truss, but sometimes remember if there's a vertical member, you need to pay attention. Sometimes we call redundancy, but I think doing the exam may not be easily see this question. But anyway, I try to use 3 steps to teach you how to do this example. The first one, if you need to remember, most likely the bottom one will be in tension, and then the upper one will be in compression based on the step 1 theory, and the step 2 theory is if we find the angle like this, if we see one is in tension, the other one is also in compression, and then we will see another example. This is the first step. If we apply the compression in here, most likely they will form compression in here. Okay, and then that's why you will see this is a compression. Sorry, compression and compression. Most likely you must have tension in here, otherwise the truss will be unstable. This is a so-called we choose Y should be in tension, and then make the building is unstable. Okay, but this one need to remember something. If something is related to this one, we also need to take care of this member. Okay, that's why axis should be taken out, may not be useful. Another type is a so-called most economic framing pan. Something like is if we see this is a shorter span, for example, this is a 5 meter and this is a 15 meter. Most likely the engineer want to use the longer span to do the secondary beam, the shorter span to do the main beam. I show you the reason is why. Because you can imagine if we change the longer span for main beam, that means all the beam will be transfer the loading to the longer span. This means, but this one the span is 15 meter. That means you can imagine this beam will have a larger moment. The size is very large and very huge, and this is not economical. That's why if we choose something like this, is a most economic design for framing pan. And this one is so-called if we need to understand normally the concrete include 4 basic elements. The first one is cement, aggregate, and water and mixture. And mixture is something nice. If we want to dry quicker, we put some aggregate inside, and if we want to put some color inside, they also put some aggregate inside. And the PFA is something like construction material. They can replace the cement sand, and that means the concrete is much more cheaper. And this is most likely the common way we do it in Hong Kong. And this is the example if the architect involves something change of the floor load, and also we need to check the engineer, and they also need to the coordinators and check the design criteria, because the design criteria is something like what is the floor load change, what is different use change. For example, if I want to change to the cup house to be a palm room, something like this, the loading should be increased larger. And also we need to examine the existing building, because if you see the existing building, you use architect will understand what is the existing use. And also you need to understand is that most likely the architect is the coordinator. And for the diffraction, you need to understand most likely it depends on the stiffness. Stiffness, we have a formula, is a B is a width, and diff is like this one, and this is power phi. And then that's why if we want to compare 2 diffraction, we need to understand this formula. Just for the I stiffness 1 and stiffness 2, they just put the formula inside. B is for example, B is 200, D is 800 power phi, and then you just use the calculator. You can find it is the difference is 1 to 4. That means if we have much more deeper, it will help the diffraction much efficiency, because this is a power phi. The standardless ratio is very important for the columns. For example, if we see many columns without the support in the intermediate, they will bend, will form the buckling, and then the column will be unstable. That means you need to remember this is the basic formula. This is a standardless ratio. This is depends on L effective. That means the column height and the end support condition. For example, if this is fixed, you can see the bending moment the curvature is less significant, but this is a pinned, you can see the deflection is much larger, and this is much more unstable. That means the first one is the end support, and this one is due to the area on this formula. This means you understand, just remember this formula, you can know how to do it. And also remember, this will be depends on the length of the column. Just mean this is the very important formula for the columns. The slender ratio is depends on the length and the support condition and the stiffness and the area. This is a so-called important element for columns you need to remember. And this is more or less the one I showed you before. Is remember, if you want to resist the lateral load, most likely we need to have a moment frame. Moment frame is the support, they will have a much more boltings there to resist the loading, and that's why you can see sometimes the beams should be like this. And for the steel building, also need to have a bracing, braced in something like this. This is like the course we call braced. And shear wall is normally we see in Hong Kong is a concrete building to take the resisting load. And this is another example. Is in Hong Kong we normally use 40D, but D is a so-called design mix. That means 40 is mean we can have the concrete can take the pressure is 40 Newton, and that's why if we see something like 20-20, that means the 20 is the aggregate size. That means the watt diameter. Okay, aggregate is watt diameter. What I'm telling before is the concrete is depends on the water aggregate. Aggregate is called the watt size and the so-called cement and mixture. And this is just remember, this is 100 is good enough. And this is a so-called diaphragm wall. Is most likely the MTR station they will use the diaphragm wall because this is a permanent type of the concrete wall. We call diaphragm wall. Most likely what they are doing is use the grabber to drill a hole, and between they don't have a temporary casing, but what they put in is a so-called bentonite. Bentonite is they can put in is to resist the soil pressure and then don't let the soil collapse inside the casing. That means this we use the bentonite. This is one of the method you need to remember, and then you know how to do it. Thank you.